All right, this video is the in-class practice we did on evaluating the derivative by the definition. And I got 2 of them done in class, but this video I'm going to probably do all 4 just so you'll have it to look at. I actually did number 1 and 4 in class, so I'm going to do those first. So if you want to look at those, and then if you want to continue watching to make sure that you know how to do these, we are going to practice this with a lab. All right, so the first one is we're going to be using this definition right here. And notice we have x's in this spot where we used to have a's. So now we're actually evaluating the derivative function. So we can put in any point we want when we're done. We just don't have to do it as a certain number at a certain time. So the first one we're going to do is we're going to do f prime of x equals the limit as h approaches 0. And then I'm going to use this function and do this here to it. So I'm going to do f of x plus h. So this is going to be x plus h cubed plus 2 times x plus h. So that is that function with f plus x plus h put in there. And then I'm going to take away the function, or subtract that function there, of x cubed plus 2x all over h. So like I told the students in class, really right there, that's the calculus is done. The rest of this is literally just algebra. Okay, so I had to fix that, make it look a little nicer. So over here on the side, I'm going to do x plus h cubed. So I have x plus h times x plus h, and when I multiply that out, I get x squared plus 2xh plus h squared. And then when I'm done with that, I'm going to multiply that by x plus h because it's cubed. And later on, we'll do something called Pascal's triangle that will make this a little bit easier for you. So this comes to be x cubed plus 2x squared h. So I multiply them all through by h plus xh squared. And then I multiply everything by h. So plus x squared h plus 2xh squared plus h cubed. And I'm going to add all that up, and then I'm going to put this right here in this spot. So I have f prime of x equals the limit as h approaches 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed. So that is this right here. I just multiplied that out. Now I'm going to do the distributive property, plus 2x plus 2h. Then I'm going to subtract and change both of those signs, so distribute the negative all over h. All right. Now, if we did this correctly, what I told everybody, this last part right here, I'll put this in purple right here, should always cancel if we did this correctly. So if I look at it, I say, oh, thanks for playing. Those do cancel, and this does cancel. So I'm happy about that because Mrs. Pond said that should cancel. So f prime of f prime of x equals the limit as h approaches 0 of 3x squared h plus 3x h squared plus h cubed plus 2h all over h. Now I look at it, if I were going to try to plug 0 in there, I'd still get 0 over 0. So what I'm going to do is factor h out of the numerator and see if I can cancel stuff that way. So I have f prime of x is the limit as h approaches 0. And I'm going to factor out the h. So I have 3x squared plus 3xh plus h squared plus 2 all over h. And lo and behold, thanks for playing, these divide to make a 1 or cancel to make a 1. So this equals the limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 2. Now, I think I can plug 0 in. So when I do, once I plug 0 in, you do not need to write limit anymore. So I got f prime of x equals 3x squared plus 3x times 0 plus 0 squared plus 2, which equals 3x squared plus 2. And the beauty of this is now I can find the derivative at any point just by plugging it into this formula. If you want to find f prime of 0, I could plug that in, f prime of 2. So you can do it for a number of x values. So I did this first one in class. I kind of skipped the second one here, and I kind of skipped the third one here. You could try these on your own. If you write this like this, you could do that one. But I actually did this fourth one in class because it has a radical and a fraction. So I thought this would be most helpful. So I'm still going to use the same f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm finding the limit with the derivative definition. So f prime of x is going to equal the limit as h approaches 0 of 1 over, now I'm just going to put x plus h in this spot, x plus h plus 2, minus, subtract the actual function, all over h. Again, like I told everybody in class, calculus is now done. It's the rest of this is algebra. So the first thing I realized that this is a complex fraction, and I want to multiply this everything by the common denominator. So it's going to be this, this right here, and it's going to be this. So I'm going to multiply everything by that. So it's going to be radical x plus 2, radical x plus h plus 2. I kind of write it on an angle because for room, x plus 2, radical x plus h plus 2, radical x plus 2, radical x plus h plus 2. And like I told students, I've always had some students every year that would actually kind of forget to do the denominator, so please don't do that. So when I do this, I get equals the limit as h approaches 0 of, now these are going to cancel, so I'm going to use a different color, but I can say thanks for playing, that's gone. So I have radical x plus 2 minus, this will cancel out, radical x plus h plus 2 all over, and I know it's nasty looking, but just write it all out just like this. Now, that is really what that is. So I'm going to kind of copy this down here because now I have some radicals in there, and I'm thinking, is there some other algebra I can do? Because I still can't put my 0 in for h because I'd still get 0 over 0. So I'm going to do this again. So I got f prime of x. Let me erase that to try this again. F prime of x equals the limit as h approaches 0. So I'm just going to write the green over again. All over h radical x plus 2 radical x plus h plus 2. Now I'm going to multiply this by the conjugate, which we talked about before, and it's going to be rationalizing this using the conjugate of the numerator. So I'm going to write the same thing. All over radical x plus 2 plus radical x plus h plus 2. And when I do that, the numerator actually comes out very nice. The only thing you have to be careful of is when you multiply this out is that you put this second radical, because when I multiply the first radical, so this is going to equal the limit as h approaches 0. Now watch what happens. This actually right here, well, you know what? I'm not going to have room up there, so let me erase that really quickly and go on the next line because I'm going to run out of room. So I'm going to do this on the next line. So when I do this one right here, so I got f prime of x equals the limit as h approaches 0. And the numerator is going to look pretty. So radical x plus 2 times radical x plus 2 is just a plain old x plus 2. Sorry, guys, I keep hitting the side button, which is erasing as I'm writing. Minus, and then if I did radical x plus h plus 2 times radical x plus h for 2, it's just a plain old x plus h plus 2, but make sure you put it in parentheses because it's going to change all the signs. And the denominator, it is long. So I'm going to write this out. And then I want you just to put this in parentheses and write what's in red right next to it. Don't multiply this out, please. It'll be a big mess. So that's what I have. So we're going to make life a little bit easier. I'm going to do this in green. I'm going to distribute here. So I have x plus 2 minus x minus h minus 2. And when I do that, I say, oh, yay, look what happened. This cancels out the negative 2 and the 2, the negative x and the x. So I end up with just a negative h on the top. And because there's a negative h up here, now these are all factors. I can cancel this out and make that just a negative 1. All right, so I have f prime of x. So I hope I didn't do too many steps in one. Is the limit as h approaches 0 of negative 1 all over this long thing, radical x plus 2, radical x plus h plus 2, times radical x plus 2 plus radical x plus h plus 2. Okay, now I can plug in the 0. So I'm going to plug in a 0 here. So you have to show me that you're plugging it in. Once you plug it in, again, you don't have to write limit anymore. So it's negative 1 over radical x plus 2. And remember, I'm plugging h as 0. X plus 0 plus 2, parentheses, x plus 2 plus radical x plus 0 plus 2. Now, I want you to notice something, so I'm going to use a different color here, green. These two right here come out to be x plus 2 times x plus 2. These two will multiply out to be an x plus 2 because radical x plus 2 times itself is just a plain old x plus 2. These two right here, you're adding, so you have a radical x plus 2 plus a radical x plus 2. This is actually 2 radical x plus 2. I have 2 of them, okay? And I'm multiplying this here. And I'll put this in parentheses so that you can see this. So this equals negative 1 over x plus 2. And I'm going to put the 2 in front, and then I have a radical. Let me erase that. That 2 is kind of sad looking. I can put the 2 up front, and this is a radical x plus 2. And I want you to remember that if you were to look at this, you could say this is the same as saying x plus 2 to the first power. And this is x plus 2 to the half power. And if the bases are the same and I'm multiplying, I add my exponents. So it's negative 1 over 2. And I can write it as x plus 2 to the 1.5 or 3/2. And that is that derivative function. So that one was a little long, but I had some Christmas colors in there. The other two, if you need more help, I can do that as a video, but I think this is good enough for you to get started. So if you need any help, please give me a call. But that's the end of this video.